The year was 2003. It was a time of great advancements in astronomical technology and exploration. Astronomers at the Mauna Kea Observatory in Hawaii were peering into the depths of our solar system. This observatory, perched high on a dormant volcano, offers one of the clearest views of the night sky on Earth. They were using the powerful Subaru telescope, a marvel of modern engineering, capable of capturing the faintest glimmers of distant celestial objects. Their target? Jupiter, the giant of our planetary family. This gas giant with its swirling storms and colorful bands has always fascinated scientists and stargazers alike. On February 8th, they spotted a faint point of light. At first it seemed like just another star, but its movement told a different story. This light was moving against the backdrop of distant stars. It was not stationary like the stars, but instead it was on a journey of its own. It was a new moon, a tiny world circling the mighty Jupiter. They named it Aoede, after one of the muses of Greek mythology, symbolizing the harmony and beauty of the cosmos. This discovery added to the already impressive collection of Jovian satellites. Jupiter is known to have dozens of moons, each with its own unique characteristics and history. Jupiter has a vast and complex system of moons. These moons range from the massive Ganymede, the largest moon in the solar system, to tiny, irregularly shaped bodies like Aoede. Aoede, however, was not alone in its celestial dance. It was part of a larger family of moons that share similar orbits and characteristics. It joined a group of other moons with peculiar orbits. These moons do not follow the typical circular paths but instead have more elongated and tilted trajectories. These were the members of the Pasiphae group. Named after another figure from Greek mythology, this group of moons is characterized by their irregular orbits, likely captured by Jupiter's gravity long ago. The Pasiphae group is a collection of Jovian moons, a fascinating ensemble of celestial bodies that orbit the gas giant Jupiter. They are named after Pasiphae, the largest member of the group, which itself is named after a figure from Greek mythology. What sets these moons apart is their unusual orbits, which are unlike the more regular paths of Jupiter's other moons. Unlike most of Jupiter's moons, which orbit in the same direction as Jupiter's rotation, these moons are different. They defy the norm. They travel in the opposite direction, a phenomenon known as retrograde motion. This is called a retrograde orbit, a term used to describe the backward motion relative to Jupiter's rotation. Their orbits are not only retrograde but also eccentric, meaning they follow elongated rather than circular paths. This means their paths around Jupiter are more elliptical than circular, adding another layer of complexity to their motion. Additionally, their orbits are highly inclined, which means they are tilted relative to Jupiter's equatorial plane. They are tilted at a significant angle relative to Jupiter's equator, making their orbits even more unusual. These orbital characteristics hinted at a shared history, a story written in their celestial motions. Scientists believe that these moons may have originated from a single parent body that was captured by Jupiter's gravity and subsequently fragmented. This theory suggests a dramatic past, where a larger body was torn apart by Jupiter's immense gravitational forces, leading to the creation of this unique family of outcasts. Today, the Pasiphae group continues to intrigue astronomers, offering clues about the dynamic processes that shape our solar system. The unusual orbits of the Pasiphae group moons tell a story of cosmic capture. Astronomers believe these moons were not born around Jupiter like its other satellites. Instead, they were once part of an asteroid that roamed the early solar system. This asteroid, drawn in by Jupiter's immense gravity, was captured into orbit. The capture process, however, was likely a violent one. The asteroid may have been torn apart by tidal forces. The fragments then became the moons we see today. While the Pasiphae group shares orbital characteristics, there are some intriguing differences among its members. One striking difference is their color. Some moons, like Pasiphae itself, are reddish in color. Others, like Sinope, another member of the group, appear gray. These color variations raise questions about the origin of the Pasiphae group. Did all these moons originate from the same parent asteroid? Or could some, like the gray Sinope, have been captured independently? The answer to this question remains a subject of ongoing research. Section 5. Unveiling Aoede, a tiny world in the darkness. Aoede, the small moon discovered in 2003, is a faint and distant world. Its estimated diameter is only about 4 kilometers, making it one of the smallest moons in the Jovian system. Its surface, likely a mix of rock and ice, reflects very little sunlight. This makes it a challenging object to observe. Despite its diminutive size, Aoede's orbit provides valuable clues about its past. Its retrograde, eccentric and inclined orbit firmly places it within the Pasiphae group, suggesting a shared history with its fellow outliers. Section 6. Naming the Muses, a Celestial Symphony. In Greek mythology, the Muses were the goddesses of inspiration for the arts and sciences. They were the daughters of Zeus, the king of the gods, who is the Roman equivalent of Jupiter. It seemed fitting to astronomers to name this distant moon after one of these inspiring figures. The name Aoede specifically means song or voice. This choice aligns with the International Astronomical Union's convention of naming outer retrograde moons with names ending in E. Section 7. Scott S. Shepherd, a shepherd of distant worlds. The discovery of Aoede was led by astronomer Scott S. Shepherd, a prolific discoverer of distant worlds. Shepherd, working with his team, has been responsible for finding numerous moons around Jupiter, Saturn, Uranus, and Neptune. His work has significantly expanded our understanding of these giant planet systems. Shepherd's expertise lies in developing advanced image processing techniques. These techniques allow him to sift through vast amounts of astronomical data and identify faint, previously unseen objects. His work is a testament to the power of human ingenuity and technology in unraveling the secrets of the cosmos. Section 8. Echoes of the Early Solar System. The story of Aoede and the Pasiphae group is more than just a tale of celestial mechanics. It offers a glimpse into the chaotic early days of our solar system. During this time, giant planets like Jupiter were still migrating to their current positions. These migrations would have disrupted the orbits of smaller objects like asteroids. Some asteroids were flung out of the solar system entirely. Others were captured by the giant planets, becoming their moons. The Pasiphae group, with their unusual orbits, stands as a testament to this turbulent past. Section 9. The Unending Quest to Explore. The discovery of Aoede, a tiny moon in a distant corner of our solar system, reminds us of the vastness and wonder of the cosmos. This small celestial body, orbiting far from the Sun, is a testament to the incredible diversity and complexity of our solar system. Each moon, planet, and asteroid holds its own unique story, waiting to be uncovered by our relentless pursuit of knowledge. It also highlights the importance of continued exploration. The missions that venture into the unknown are not just about gathering data, they are about pushing the boundaries of human capability and imagination. Every mission, whether manned or unmanned, represents a leap forward in our understanding of the universe and our place within it. Each new discovery, no matter how small, adds a piece to the puzzle of our cosmic origins. The data collected from these missions is meticulously analyzed by scientists who work tirelessly to decode the secrets of the cosmos. Their findings not only enhance our scientific knowledge, but also inspire new generations of explorers and dreamers. As we continue to develop more powerful telescopes and spacecraft, we can look forward to uncovering even more secrets hidden within our solar system and beyond. The advancements in technology allow us to peer deeper into space, revealing phenomena that were once beyond our reach. These technological marvels are the result of years of innovation and dedication by engineers and scientists. The quest to explore, to understand our place in the universe, is a journey that will continue to inspire generations to come. As we gaze at the stars, we are reminded of the endless possibilities that lie ahead. The spirit of exploration is deeply ingrained in human nature, driving us to seek out new horizons and expand our understanding of the cosmos. This unending quest is not just about scientific discovery, it is about the human spirit's desire to reach for the stars and beyond.